Okay, just to give you my quick background, I did my PhD from Hopkins in computer science, joined IBM Research Division 1984 to 2000, was a researcher, wanted to be a professor for the beginning, taught at MIT, then went back. And interestingly, in 92, we were given, a CEO of a paper mill came to us and wanted us to improve the paper mill end to end, all the way from providing pulp to the paper machines, to cutting and winding the paper, providing it to New York Times. This is 92 to 95, and IBM was still a hardware company. We were in IBM Research. We were fortunately able to improve the solution by, their revenue, or rather their costs, by about 2%, which was about $10 million. So that was a very interesting, discussion. But it used to take us almost 2 days to create such a solution, to do scheduling for that amount. So, and that was because we were using machine learning, and the processing power, etc., was quite low. So anytime somebody had to reschedule it, it would still take a day and would run out of time. Much has gone on since then. Started a company about 10 months ago. The word SCRY means crystal ball gazing. And I'm not going to tell you much about SCRY other than we are about 25 people doing data science. But tell you about how do you create end-to-end solutions. A lot of the questions, I think, discussion that was going on is of interest as to what we are doing and how we look at the whole universe. So some of the discussion is on service workflows. I'll give you 2 examples and some key performance indicators. Machine learning and natural language processing, just a very quick overview as to why this is important. Underlying methodology in choosing a platform, building blocks needed for an analytic solution, and again, any discussions and comments that people may have. So today, if you look at, I was talking about paper mills, but today if you go to Ford or you go to a manufacturing company, they would immediately, you ask Ford as to how they build a Taurus. They would tell you how many nuts, how many bolts go in a Taurus, how much is done by robot, how much is done by humans, and so on. So the whole workflow is very well defined. But you go to a hospital and you ask them, let's say even Mass General, and you ask them how many people will show up in an emergency room next week. And they would say 192 showed up last week, 294 showed up the week before. They will add up, take an average, and they will give you an answer. But suppose it's going to snow next week, then more people will show up with broken bones, with potentially back injuries, potentially even with angina or heart problems, and so on. So in services industry, in fact, the workflows are typically amorphous, and they are more in the realm of art rather than science. So, and services, of course, industries are healthcare, retail, utilities, telecom, banking, etc. So some of the workflow examples would be, suppose I am running an IT help desk, or I'm an IT department, which consists, of course, hardware, software, various routers, switches, equipment, lease lines, and all the stuff. Where will things break down? What is the likelihood of let's say, a head of the IT department for Citibank? Which are the ATM machines which are going to go down because the lease lines are going down or something like that, right? Another example is, I think people earlier were discussing call centers and collaboration networks. So the other interesting example is, similarly, I call Comcast. Because I'm calling from my phone, the person already knows my name. Because of that, the question then comes, shouldn't the call center representative have a decision support system there, knows where I'm living, maybe I'm living in a decent localities, then there is a chances of upsell or cross-sell, and can then tell me, hey, your box is already more than 3 years old. Can we change your box? Because if it's 7 years old box, they're themselves handling old version of it. So, so things like that, which are related to decision support, whether it is taking medications after a person has left the hospital, or providing decision support, those are some of the work examples. So the whole, I mean, if you look at the entire system, not just solving a portion of a problem, but the entire system, the system consists of 3 or 4 pieces. One is codifying these workflows, collate and harmonize clients' data, which I'll talk a great deal about. Then, of course, doing algorithms and so on and so forth. Yeah. So here is one example what happens in a contact center workflow. So I call Comcast. I may call them. I may send them email, connect via phone, via web app, via web chat. I mean, currently in many cases, even these systems are not linked. So forget about having a unified data. The data actually resides in different systems. So what is the likelihood, when I'm calling, what is the likelihood of the contact center representative doing cross-sell or upsell? How does he save time and money for Comcast or for me? How does he improve my customer satisfaction? And this implies, of course, at the top level, I mean, at the algorithms level, it implies, or at the module level, it implies you have to collect the data, harmonize the data. You need to know a lot about the data. So need to have domain expertise about Comcast and how it works, or how the entire industry works. Then show the data, which is descriptive analytics, targeting and segmentation of people who are calling in or who are the clients or potential clients, people scheduling, matching of calls to the right representatives, and then figuring out the ways of cross-selling. Yeah. Patient flow, similar thing. Patient walks in the hospital. You have the entire, a workflow for the patient. You have, again, nurses, equipment, beds, doctors, medication supplies, all are making part of the workflow that a person goes through. And then the key performance indicators typically in a workflow, which is no different than, not much different than that in a manufacturing company, timeliness to market, quality of the product or service, cash flow, which may be increasing revenue, reducing costs, experience, risks, etc. And the data is coming from all over the place, market research data, syndicated research data, demographic data, economic data, internal and external transaction data, cell phone data, call center data, machine data, social media data, ERP and CRM data. So a lot of data that needs to be actually merged through. So let me just take why is this whole big data science and the entire area during the last 5 or 6 years become so important? So let me just digress and discuss the last 20 years very quickly. So Gordon Moore in 1965 said that basically every 18 months, processing power and memory, the cost would decrease by half, or in other words, they would increase by double every 18 months. So if you look at that over a period of 30 years, that means it has gone up by 1 million times. Right? So what we were able to do in the paper mill scheduling about in 3,000 minutes, you can do it literally using the processing power and the memory of your smartphone in 3 minutes today. So that's definitely one of the most important things that has taken place during the last 20, 30 years, that Moore's law has been, in spite of what people felt, Moore's law has been continuing to increase the power and memory. The second is parallel computation is now possible with respect to MapReduce first, and now Hadoop, which allows parallel computation, and then, of course, then Spark, Storm, and other processing systems are coming in which improve it further. And then the algorithms part. For a long period, developing parallel computation algorithms was part of theoretical computer science or academic places like MIT or Harvard or Stanford, IBM and AT&T, but now it's down in the trenches where people can use it. So let me skip the examples and go to how do you create solutions. So the way we look at it is what we call analytic solutions using a well-known data information knowledge pyramid. The idea is that there are many databases. You need to first combine and cleanse these databases. That is what creates information. So information is what you can show about the past. So that is descriptive analytics. So you can visualize it. You can use any of the visualization software tools. There are at least 51 known so far. And then pretty much every company has its own visualization tools, which it wants to now, of course, promote. After you've done that, you can do analytics, whether it is using statistics or computer science, which is machine learning, natural language processing, etc., or a combination of both to provide knowledge. And then out of that comes predictive analytics, what is going to happen in the future, and potentially even prescriptive analytics. How can we change some of the variables to change things in our, hopefully in our way in the future? And that is providing actionable insights, or one can argue that's kind of providing wisdom, where I can look at it and say, look, Alok Aggarwal is a good customer, has been with Comcast for 8 years. Maybe we can actually sell, if we give him a free higher-end box, let's say a triple play box for the next 3 months, maybe he will buy it. So that's providing actionable insights. And then at the top is, of course, consulting or providing, doing action on the actionable insights. So this is the way we often look at it, at the system. And in our case, we are using a platform which is completely open source. The reason is we are providing the system, the solution goes to the end client. We don't want the end client to be paying too much in terms of the underlying licenses. So as much as possible, we will not use SAS, but we would use R as a programming language. Similarly, we would use otherwise Apache open source, so that the amount of, there is still, don't get me wrong, there is still cost involved in using these solutions, but the cost is substantially lower than, for example, going to Informatica and getting licenses for Informatica, or for that matter, for Tableau, getting a software license. Yeah. So the entire platform needs, that we at least use, is open source. But you need to figure out as to what are the components, because ultimately it is technology. If you're going to create a solution, whether for yourself or to sell it to other customers, it's a solution that you need to do. The approach, so what is needed to create these solutions from a human perspective? The most important thing is, and I think the previous panel was talking a lot about it, and what we have seen is that the most important thing is cleansing and harmonizing data. And it's not as simple as just doing simple extract, transform, load, because you may have to write thesaurus, you may have to cleanse data, somebody may have written sleepiness in some place, others may have written drowsiness in another place. So you need to cleanse and harmonize the data quite a bit. Professional services in terms of providing people from wherever around the world, whether it's San Jose, whether it's Raleigh, Boston, India, China, etc. Of course, you need these people because there is a shortage of such people who can create such solutions, who can provide some analytics of this kind. Automate as much as possible, because otherwise it will take too much time. So you can't automate everything. You have to, some of the cleansing and harmonizing of the data has to be done by humans. There is no way, at least right now, that we know that everything can be automated, and then try and create a unified solution. So the composition of the team typically in creating a solution consists of 3 or 4 different units. So one is computer science application developers. So these are people who know Java, who know C, who know Linux, because you need to put all the modules together, and that is a very important thing. That's cannot be done by data scientists or analytics people. So if you're creating a complete solution, you have to understand that a substantial portion of the team that is creating a solution will be composed of people who are very good at core Java, for example, or Linux operating systems. Of course, you need a lot of people who know statistics, typically what we have seen is we need about 20% of the people. A team of 10 would have 2 people at least knowing statistics, Bayesian analysis, R, and machine learning, and so on. The other thing is you need domain experts. So if you are working in the healthcare domain, for example, if I'm working in the healthcare domain, I do not have any domain expertise in healthcare. I'm not a doctor, nurse, etc. And without domain expertise, the whole system actually goes for a toss. Neither with your end client believe you, nor would you get good results out of it, because you won't even understand the problem so well that the client will take you seriously. And then, of course, you need some additional people like business intelligence professionals who can either take Tableau-type software and provide dashboards and MIS reports, or they can build those. Yeah. So it's we tend to, I think a lot of people in this domain tend to actually concentrate only on the algorithms development part, only on the statistics, modeling, and in computer science, machine learning, neural networks, etc., of the whole thing. But in effect, if you're really developing a solution, only 20% of that, maybe 25% of that work goes into that area. On the other hand, 40%, as I said earlier, is actually cleansing data depending on the business problem and having a domain expertise in that area. So just to, explain it a bit more, in terms of feature requirements, of course, you would need descriptive statistical analysis, people who would know that, parallelized modeling algorithms, classification, machine learning expertise. You need data integration, and that's, data integration and data cleansing is a very big aspect of it, which basically implies not only data cleansing at a metadata level, but as I was saying, at a metadata level, you can say, okay, I want to deduplicate all the records. But then if you're working in healthcare, sleepiness and drowsiness probably are the same things. And therefore, you want to create a thesaurus or an ontology so that you essentially deduplicate at a semantic level also. So data integration or cleansing, munging, wrangling of data is extremely important. Data visualization is the other thing, and then the integration and development of the whole system is the other aspect. And then comes in the very nitty-gritty, if it's going to be a solution, then comes in the very nitty-gritty of providing platform support, providing database support, and so on, which, as I said, cannot be completely ignored either. So the entire schematic of putting together a solution looks as follows. You have a database connected to various databases. You have various ways of cleansing and munging data. Some of it is simple extract, transform, load. Some of it is writing machine learning algorithms or other algorithms to cleanse and munch data. Then you store it in a data mart, which is related to the business problem that you're storing. Then you run your analytics on top of it, whether it is statistical, whether it's computer science, whether it's a combination of all them. And then you begin to show it in some form of manner via visualization tool, whether it's Burst or Tableau, or via portals that you may create. So this is how the entire system looks like. So let me stop here and actually take questions.
Who has any questions? So this is actually a really great overview about data science, right? And what it means to be a data scientist and creating teams and companies. Does anybody have any questions? Yes.
Yeah, thank you. It's a great knowledge, information for us. The question I have is when you start the project, building the solution, I think the first step is we go to the business and ask him the questions. So what are the good questions? What exactly you look for so that you can really extract the information that you get from this big data set?
So I missed out one slide. I thought I was running out of time. So let me now go to that slide since you asked that question. And that's a great question. So the whole idea is to meet the client and understand the use case. So what exactly is the client trying to solve? Because unless you have a properly well-defined problem, and then whether you have the required data underneath it, are the two most important things that you need to understand. So in our case, we spend anywhere from 1 day to 2 weeks with client, and client doesn't mean just the business owner, but also his team or her team who have the necessary knowledge, and then analyze the use case to understand whether we can create a go-to plan, whether we can create a data solution in the whole process, which a lot of it again comes down to, do we even have the data to answer the problem that is being solved? Once that is done, and then we would, 2 weeks we give within the 2 weeks we would give actually the general solution to the client. This is what we plan to do. Try to break it up into pieces so that it becomes sub-projects rather than a huge 8-month project. We'll break it up into 4 or 5 pieces so that the client can see as to where we're going along. Given that these are not, building a solution in big data science is more of a research and advanced development process and not building a simple software solution, we tend not to use the usual computer software methodology of a waterfall that you do quality assurance and testing in the end, but we tend to do more of agile Scrum methodology where the team is about 10 people, 8 to 10 people total, creating a solution. We haven't used so far more than 12 or 13 people ever on a project, and they meet every week, and they have weekly meetings and so on, to make sure that they're following the process of creating this stuff. What does it mean then to, once we have analyzed the use case, then we collect internal and external data, and that's a milestone. That's a milestone that's an important one, because if the data again is not missing, or if the data is too noisy, which happens every now and then we may not be able to answer the problem. For example, for one client, we got 300 records, which were about from their IT help desk, which were about various things, why the IT help desk was called. And out of those 300 records, 225 records were missing ticket ID numbers. So out of those 225, we could, since the numbers were small, we could by hand actually figure out what the ticket ID numbers for half of them were. But then they were missing actually why was the ticket open. So that's a clear example. The numbers were becoming so small, that was clearly an example there where we could not go ahead. So once a milestone does occur after collecting the data to make sure that we can actually try and answer the problem to the extent that we can. Most of this was a question asked in the previous panel. Most of the people do ask us about the return on investment. So people are becoming very, very concerned about the hype with the big data science. Clearly big data science has done very well in the marketing domain. Getting more and more, as I was talking about GE, getting more and more into Internet of Things domain, whether the things are GE systems in hospitals or an excavating machine by Caterpillar, mining in somewhere, etc. So they do ask in the first round itself when we meet them as to what we expect as a return on investment. Obviously, we're not able to tell them upfront whether we believe that we can improve the system by 2% or 4%, but they are looking for some X% improvement in general. So, and by the way, a lot of people think that big data science can improve things by orders of magnitude. Our view is very different. If we can improve the system by 5%, we are very happy. So just to give you an example, in the US, there are about 5,750 hospitals. Total GDP of US hospitals is $1 trillion, about 1/17 of the total GDP of US. But they work on 3% profit margins on an average. So if we are able to actually improve, lo and behold, by 5%, we have improved their profit margin from 3% to 8%, so about more than 150%. So people are our clients are very interested in that. And then, of course, we as I said, we put the system together. We have milestones that we run through. Yeah. Any? Yeah.
Just so you know, we have about another 15 minutes.
Oh, okay.
Terrific. Please.
Hi, it's been a terrific presentation, and I hope the slides will be available.
Sure.
I had a question about governance rules. Does that become kind of a, I don't know if I'd say political, but another challenge beyond the technology of moving data from, in some cases, secure systems that are secured in one way into the new big data repository and having to satisfy whatever management and governance concerns there are about that data?
Excellent question. I think that's the one of the reasons also why we have a milestone after collecting the data, because it becomes a political issue, as you rightly said. The IT department may or may not want to give the data to the business owner because of various reasons, because they're worried that the data may get corrupted. They are worried that the data belongs to them. If somebody else comes in, the data would have been changed, and so on and so forth. So this whole notion of getting the data and moving, cleansing, munging, etc., is a very, very important issue that we need to handle upfront. And in fact, about, I would say, 1/3 of our projects do not go ahead beyond the second stage because internally, our business client is not able to get the data easily. So in fact, it's much easier to get external data than to get internal data. So again, going back to hospitals, for example, Medicare has released a lot of the data. I mean, you can buy about 1% of Medicare data for the last year, which is enormous, for about $21,000. So it's much easier for us to do that analysis rather than getting hospitals' internal data on their EMR systems, right, which they own. And I mean, often you would hear, going back to political aspects of it, often the business owner in the hospital would go to the IT department. The IT department would say, no, we don't own the data. The EMR companies like Cerner or Epic own the data, which is not true. So it often becomes a very, very important, it becomes a stop the project, I would say, statement. Yeah.
Have you discovered any tips, tricks, subterfuge that helps you get through that?
The only thing what we have found is to go as high as we can in the organization, so that some of these challenges, if it's coming down from the top, the hope is some of these challenges can be mitigated or reduced, not avoided. I mean, we face the data problem that you mentioned internally, governance, stewardship, political issues, all of that combined to me, that's the biggest problem, actually. Yeah.
HIPAA compliance is any issue for you?
No, HIPAA, see, that's the interesting part. We work a lot with banks and hospitals, etc. There are a lot of rules and regulations and compliance issues coming from the Department of Treasury, coming from HIPAA, etc. But actually, none of them are real issues, because the data anyway, in most cases, is fairly strongly encrypted. We don't get to see the name of the patient or the name of the client, etc. So those are almost non-issues. And that's the reason why Medicare today is giving 1% data out for $21,000, which is really, reasonable. I would say almost immaterial in terms of the expense. Of course, you have to tell Medicare as to what you're trying to solve the problem, whether it is adherence to medication after the patient was discharged from the hospital or hospital readmissions. But none of these are issues. They do become issues if you want to send data outside the country. So what we tend to do is, for most of the data work, at the client site to avoid any such issues. Yes, sir.
Don't you need permission from the patients to mine their data?
Not if the data has been already encrypted.
I'll talk to you offline. That's not what I understand.
Okay.
Especially when you're dealing with SSRI or behavioral health, mental health, and that's where the informed consent
Yes.
that comes into play for each incident, not really as a blanket statement.
So we are not dealing at the individual patient's data level, right? We are dealing at, for example, there would be SEER database which would provide a cancer registry, or Medicare data that is coming to us that a patient X was admitted, had such and such, Medicare paid such and such, chemotherapy was given so such and such. These were the comments given on that. That Medicare is actually giving that data out. So clearly, since Medicare is releasing that data, and we're not working on an individual patient data, and we're not working, by the way, on related to mental diseases anyway, to neurology. We haven't gone there. We've worked so far in areas such as oncology, cancer, hematology, and so on, and we haven't faced any such things, and we can discuss that at the end of the talk. Yeah.
Also in the same thought, especially in the healthcare world, when you're dealing with the CMS data, it's a lot more to do with the claims aspect of it, a lot more financial, not very much of a clinical context.
Sorry?
Especially the claims data the CMS gives is very much revenue aspect of it, not very much clinical aspect. Like in all those, code and the procedure codes and the diagnosis code, but they were designed primarily from the revenue and the billing perspective. Sure. And they do not have the entire context, especially clinical side. So from the population health, even is sort of fictitious number, what you get out of that research.
Right.
It's a good start, though.
It's a good start.
Yeah.
And obviously, as we're discussing, data issues keep coming up. From various people as to what is allowed, what is not allowed. Sure. But we have actually, from one hospital, we have even gotten EMR data on a cleansed basis. No name basis, which contains actually the patients, the comments made by the doctors and nurses about that this patient actually had low immunity and had to be given Neupogen and so on. Right. Because that is what becomes very interesting. It's more than just insurance data that you rightly said.
Exactly. I think this is just a common question regarding governance aspect of it and how to get information from there. Yeah. It all boils down to what was the business problem we are trying to address, and whose that problem is. If it's a company-wide, then it filters out. It's much easier to have access. If it's on the middle management type, then it becomes a challenge because it's not really aligned with the business strategy side of it. So always look up problem, which is addressing some of the business vision and strategy, and then you go back around there.
Wow, these are great questions. Anybody else have a question? We've got a few more minutes here. We've got a great resource in front of us. Come on, I know someone. Okay, there we go.
What's your experience has been working with the healthcare world? My experience is data acquisitions and the harmonization it takes about 70-80% of the time.
So I think there are two things that we have been fairly frustrated with. One is the data acquisition from the healthcare. But I think the other one is a lot of the stuff where actually improvements are necessary and can be done is related to hospitals. And hospitals are neither that interested right now, nor are they good payers. So getting them to pay for the work that you would do for them is is almost pulling teeth out of them. It's much easier for us to work, frankly, with banks and insurance companies in other areas. And yet, really there is so much low-hanging fruit in the hospital domain that it is kind of sad. And there is so much required because, whereas I was talking about 3 to 5% improvement in banks or in other areas, in CPG and retail companies, in hospitals, we believe that the improvement could be easily 15% or so by using just various aspects of data. For example, there was a recent report which said that these 7,500 hospitals combined together actually end up throwing away about $18 million worth of syringes and gauzes every year because they have expired or whatever. So, I mean, that just shows how, and I mean, not talking about medicine, we're not talking about other things. I mean, we've done a lot of surveys with nurses and orderlies, etc. 60% of a hospital's cost goes into paying for nurses, orderlies, because the doctor's cost is usually separate. It's only a very small amount of, a few hospitals have doctors on their rolls. Most of them employ them as consultants. So that's not included in the 1 trillion. So 60%, 55 to 60% is that of nurses and orderlies. And because they do not know how to do scheduling of nurses, they have to call nurses at the last minute, thereby paying overtime 1.5 times. Sometimes the nurses are not available, so they may have to get nurses from outside, thereby paying them 3 times. So there is a lot of places, where you can actually save with respect to hospital costs and improve the quality provided to the patients. But that's one of our biggest frustrations. Okay.
Any other questions? Yes, we have someone over here.
Yeah, as you mentioned about use cases, so normally clients have the defined use case, or they just have an idea and you are developing use case?
Yeah, so that's where the first 1 day to 2 weeks goes, right? 1 day is typically where the client already has a very good use case, like the contact center analytics case I was talking about earlier. So this particular, we are building this one, a pretty large system, about, couple of $1 million worth system for a contact center analytics company. And that particular one is where the client already had the use case fairly well defined. Look, we want to sell this on top of our infrastructure to the end clients, and their end clients are Comcast, AT&T, Verizon, etc. So they wanted us to build the entire system. Right, so it was fairly well defined. Of course, we modified along with them what is possible, what is not possible, where is the data coming from, and so on. But it was, at least in this particular case, the use case was very well defined. Now, there is another company which is in the business of selling cognacs and champagnes and wine, etc. It makes them, but it doesn't know who the customers are, end customers, because they sell it through distributors. It goes to wine shops and liquor stores and, of course, restaurants and so on. So they do not even have, they want to improve. Obviously, everyone wants to improve the metrics that I was talking about, the timeliness, quality, cash flow, and so on, but they don't even know how to go about doing it. So with them, we are actually trying to figure out a use case figure out the problem given the data. Usually they know what the problem is. The question is whether they have the data to solve that problem. So problems, of course, everyone knows. Look, I want to improve my cash flow. I want to improve my revenue. Whether it is reduce my churn, whether it is increase the better paying clients, etc. Problems are, at some level, I would say 70% of the problems are generic in nature, right? Which is all to do with return on investment. I want to improve my cash flow, or I want to improve my customer satisfaction.
Great. Yeah. Coming right over. Guys, this is a great session here. We got some great answers.
In the healthcare space, have you looked at antimicrobial stewardship as a potential application? No?
No.
There's huge opportunities there for improvement.
Good. I'll talk to you later.
Sure.
The question for us, of course, we're a startup and a profit-making startup at some point, is whether we can make money off it or not, as I said.
There's a lot of money to be made there.
Yeah. Good. So we'll love to talk to you.
Oh, it relates to antimicrobial stewardship. Essentially, the issue is that are you applying the right antibiotics and the most cost-effective antibiotics that will actually treat the infection that's occurring in that patient, and not over-prescribing. And, so it's a key issue in hospitals as you look at antibiotics being effective going forward, and both treating that person, but also creating a basis for successful use in the future.
So we actually created a solution which was a cost-benefit analysis of cancer therapies for breast cancer. So as you probably know, in all these protocols, and not all, but at least in the top 40 or so cancers, breast cancer, kidney, prostate, etc., lung cancer, the protocols, basic protocols are well defined by NCCN, National Cancer Comprehensive Network. So we actually took and actually programmed them to see as to whether one particular therapy, maybe the drugs are that by Novartis versus another therapy where the drugs may be by Genentech Roche, which one is costlier? Does it improve the quality of life for the patient? Does it improve the survival after 5 years? And various other parameters. Again, what we realized were there were no real buyers for it. That's why I said the money issue is always important for us. And that's why we stopped at, because we thought it would be a great idea. I mean, you go to a bank with something like that and say, I can do a cost-benefit analysis for you, the bank would literally jump at you, right? And in this case, the doctor said, yeah, this is interesting to know, but we didn't find any takers who would be willing to pay for it. Because we believe that, I mean, as you said, whether it's antibiotics, we're looking at various other things about, whether you can substitute one thing for another and actually improve quality and reduce costs simultaneously. But we didn't find any takers. But that's why I would love to talk to you. Okay?
Yeah. Actually, it's continuation of your questions. Actually, there was a project called OMAP. It's an observational medical evidence panel by Novartis as well as AstraZeneca, and they were comparing all those kind of effectivity from the real observational data.
So we have done quite a few interesting. I mean, on the side, there is a particular drug called Tarceva given to cancer patients. So we just looked at Tarceva and looked at, again, natural language processing and machine learning, and took just data coming from social media. What are people who are taking Tarceva talking about? And what we found was 30% of the people taking Tarceva were actually complaining of more cough. And yet, Merck, which makes Tarceva, does not have cough as an indication, as a contraindication for taking Tarceva. So there are very many, that's why I keep saying healthcare is a great place where big data science and analytics can be employed. And I'm coming from actually a conference in Philadelphia from pharmaceutical companies. It's even more evident that they're at least 4 to 5 years behind the banking world particularly. And I think the pharmaceutical companies are particularly interested, but it's not always clear that the money can be made from the pharma companies. It's probably is more from providers, self-insured, and hospitals, where the money for many of these things may have to come from, or we'll have to figure out who pays for it.
So I don't know about you, but that 15 to 20 minutes went by pretty darn quick with all your questions and some great answers.
Sorry, I thought that talk was only for 30 minutes.
No.
I did not, not that it's a bad thing to have more questions, but...
I don't know about you guys, but I'm glad we were able to have those questions asked, right? So terrific. So this, we're coming up. Thank you so much. We really appreciate it. Please give them a round of applause.
Thank you.